Hi, this is a brief video, Introduction to Electronic Healthcare Record Interoperability, especially using the HL7 FHIR standard. And my name is Terry Sippel-Schmidt. So a couple of things we're going to go through. We're going to go over EHR adoption in the United States and what are the drivers. We're going to talk about what does it take for two different computers or two different applications, really, not only to communicate, but to interoperate. And that would be a data model, transport layer, and semantics. We'll go through each of those. We're going to talk about the current healthcare interoperability standards in use today, which is called HL7 version 2, which is a predecessor of HL7 FHIR. We're going to talk about the architecture of HL7 FHIR and what CRUDS, or create, read, update, delete, and search stands for and why it's important. We're going to talk about how HL7 FHIR works. And finally, we're going to talk about the benefits of HL7 FHIR. In the United States in 2010, 2011, 2012 was the ONC, the Office of the National Coordinator, High-Tech Act, which funded billions of dollars worth of EHR installation in healthcare systems across the United States. During the beginning of those years, as different healthcare institutions began to install electronic healthcare records, this thing called meaningful use through ONC became available. And meaningful use made one of the requirements interoperability and made sure that the data was accessible to other parts of the hospital. So we went from having a carrot, which is that sites could install an electronic healthcare record or get funding for it, to a stick, which meant that now there were actually fines associated with not implementing electronic healthcare records, which turned out to be, which did not have data accessibility. Let's take a step back. Let's talk about HL7 version 2, because to understand why FHIR is so important, you really have to understand where we are today. 99% of the messages today in a hospital system are using a standard called HL7 version 2. HL7 stands for Health Language 7, where 7 is the highest network layer in an ISO, or an International Standards Organization network model. Version 2 began in 1980s, and it was very effective. It actually still is very effective. So let's talk about what comes out of electronic healthcare record as it goes into what's called an HL7 version 2 interface engine, which every healthcare system in the United States and really everywhere has today, and usually they have multiple of them. So what's contained in an HL7 version 2 message? It could be patient information, for example, from admission or discharge. It can be prescriptions, it can be lab values, lab reports, it can be radiology or cardiology reports. All of this kind of information is sent from an electronic healthcare record to this interface engine, which literally we use the word sprays these messages out across the enterprise. You'll see all these different databases sitting out there. Maybe one's in radiology with a very large database with all the image sets. Maybe one's over in laboratory, one's in physical therapy. You've got one down in cardiology. At Johns Hopkins alone, there are hundreds of these databases. At Johns Hopkins alone, there are over 1 million of these HL7 messages sprayed about every day. If you're wondering what your IT system, what your IT staff is working on, they're working on maintaining all of these databases, because every one of these databases has to be updated, has to be synchronized, has to be backed up. And they're working on maintaining all of these millions of messages that are going out over the day. Basically, they're a hamster on a hamster wheel. Let's actually take a look at an HL7 message so that you recognize what the content of an HL7 message. HL7 is text-based. There's no security. For example, an HL7 message is made up of different segments. The first segment is MSH, and that's a message header segment. You can have other segments, for example, a PID, or patient identification segment. And down here, we have a PRB, or problem segment. So let's go take a look at the patient ID segment. HL7 version 2 is made up of hats, which is this carrot, and pipes, which is this line right here. And so, for example, patient identifier is PID element 3. And so you have to go through and you have to count pipes. So get to past the third pipe. 1, 2, 3. So this is the medical record number, patient identifier. And then you can count some carrots. It'll tell you who assigned it. And it was West Hospital System. And then this is the type. MR stands for medical record. So it's a medical record number or patient identifier. And that's how you actually read an HL7 message. PID 5 is patient name. So over here we have the patient name. You have patient date of birth. You have patient sex. And then social security number is PID 18. So you have to go and count 18 of these pipes, and you'll get to social security number. And there's lots more, a lot more than 18. There's 50 or 60. If a software developer misses one of these pipes, the data is corrupted, and now you have to deal with all those different databases being updated and corrected. Let's go take a look at the problem segment. Third component of a problem segment is actually the problem, or like often chief complaint condition. So let's go count to 3. 1, 2, 3. Over here, you can see a code system. This is actually an ICD-10 code for type 1 diabetes. You can see later on, you can see that the onset date, you can see that it's still active. But that's how you read an HL7 version 2 message. It's text. So let's switch gears. What is HL7 FHIR? FHIR stands for Fast Healthcare Interoperable Resources. What is it actually? What it is it's an international standard. FHIR was actually not started in the United States and is based on interoperability. So we don't expect every AHR database to be able to store information in HL7 FHIR. It's between two applications on the wire, and that's where HL7 FHIR comes into play. Unlike some other standards, HL7 FHIR is free and it's open. As a matter of fact, anyone can participate in the development of HL7 FHIR. You just join a meeting. HL7 FHIR has a lot of different versions. Right now, R4 is probably the version that everyone is using, especially in the United States. R5 is already completed, and they're working on standard for trial use number 6. However, in the United States, with the Office of the National Coordinator, there's an act called the 21st Century Cures Act, and that particular act requires R4. So in the United States, we're going to be focused on R4 for a while. FHIR also includes a bunch of infrastructure and tools, and there's a lot of FHIR accelerators to get certain projects off the ground. What it does not require is it does not require a new AHR. Okay, let's take a step back and talk about what does interoperability mean. There are really 3 components to make 2 systems interoperable. One is a data model. So for example, a patient can have multiple prescriptions. One is a transport model. How is the first application going to actually transport or send the information to the second application? And the third is semantics. Semantics is a common language. How do we know that when we send something from the first application to the second application, that they're speaking the same language and that they're going to be able to understand exactly what that means? In terms of a prescription, the data model is going to require that we identify the type of medicine. It's going to require that we identify perhaps the number of pills, or perhaps the method of taking the medicine, the number of pills to take per day, perhaps time of day, the number of refills allowed. The transport is, how is this prescription going to get from a primary care physician office over to the pharmacy so that it can actually be filled? Semantics means when we say one type of medication, what exactly does that mean to the pharmacist at the other end? All right, let's talk about each of those. Data model. In HL7 FHIR, and you can go up to this, I'm going to use R4. You can go up to this URL up here. It's free and it's open on the web. If you go to this website right here, this is the web page that you'll see. Probably the easiest way to get started in HL7 FHIR is to understand what the data model looks like and what data is going back and forth. So there's this tab right here called Resources. Go ahead and take some time and click on that tab. When you get to that page, this is only a portion of the page, you're going to see hundreds of resources. A resource is a definition of a particular piece of information. It's kind of like an object definition if you're in computer science. You can see that we have a patient, and defines what is a patient. Patient has a name, and they have a medical record number, and they have a surname and a first name and probably a middle name, and they have an address and a cell phone and a home phone and a social security number. And so there's all sorts of pieces of information that define what a patient is, and it defines a patient consistently across any application. Another example is a diagnostic report. Maybe it's a radiology report. Another example is a medication request. So it's an order for a medication, a care plan, a nutrition order. A service request is like an order for you'd have a service request to order a chest x-ray. So it's a way to communicate a request for service. All of these things are defined in a lot more detail on the FHIR website. So again, please take some time and go take a look and just play around with those. Patient is probably the easiest to understand. So if you're going to start anywhere, I'd start with patient. Let's go take a look at medication request, though. So when you click on any of the resources, scroll down a little bit and you'll get to what's called the structure or the content. So if you take a look at what the content of this resource, you can see that there's a status for the reason, there's an intent, there's a priority for getting this medication filled. There's a do not perform. That's if this was canceled for some reason, why was it canceled? And then we get down here to the medication, and that's like what type of medication is being prescribed. We can go down further. You get instructions on how to take the medication. You can get an initial fill when you're dispensing the medication. That might include a quantity, that might include a duration, the number of repeats allowed, which is the number of refills authorized. So this is part of not only the data model, but also the semantics. It's very important when one application is speaking to another application that they're going to use initial fill in exactly as it's identified here with the upper and the lower case. And when one application is talking to the other application, it will mean exactly that the first fill, the quantity of the first time that the prescription is filled. Right, let's switch gears a little bit. Transport. Applications on the internet use what's called a client-server architecture. So for example, if you are going to order something from Amazon, you've got an Amazon application perhaps on your cell phone, and you're talking to a server over the internet. Or if you're going to do a streaming service for music, you have a music application on your laptop, and you're going to contact a server over the internet, over HTTP, and you're going to stream the music from the database. In our case, we have applications which are supporting FHIR. So FHIR is really over here across the wire. But we have applications which support FHIR, and they're talking to an EHR, which in our case is our server. The way that they talk to EHRs, or any application in a client-server architecture using RESTful services talks to the server, a series of commands, which they often use the acronym CRUDS, create, which, for example, could be a new medication request. Create could be an admission, a new patient was admitted, so perhaps it's the creation for a new patient. A read, which pharmacy does this patient want to go to? Or perhaps give me the most recent radiology report. Update, new insurance plan for a patient for a medication, or perhaps it's an address change for a patient. Delete and deprecate. You don't delete medical data. Let's just not go to delete. Search. When you've got a large EHR database like this with a lot of information, search is really important because if you can't find it, it doesn't exist. But perhaps you've got an application over here in cardiology, which supports FHIR, and they're looking for all of the prior prescriptions for a patient. The way that it works across the internet, and even when it's working on an intranet, is using something called RESTful services. I'm sure you've seen HTTP or HTTPS when you're browsing the internet. It stands for Hypertext Transfer Protocol. And the way that you read an API, or an application programmer's interface, the way that you read an API is the first set of information is the server. Where are you going on the internet? So this is a unique address, just like Amazon.com. In our case, this is a public server, which is supplied by a company called Happy. And this is their URL. And we're saying to use the R4 version of it. Then this is where FHIR becomes unique. So we're saying the type of resource or the type of information we want replied back to us is going to be a patient object or a patient resource where, and I'm going to say the name is equal to hey. So I'm going to step out of this for a second. I'm going to just show it to you. So I'm sure that all of you recognize this as a Google Chrome browser. And up here in the address locator, I've typed that in, HTTP. You'll notice I'm not using any security because there's no S, but that's okay. This is just a learning experience. It's a public server. There's no real patient data on it. I'm going to Happy, which is the public server I was referring to, and I'm going to use R4. And here's my resource I'm asking for, and I'm going to say where name equals hey. So I'm going to look for all the patients named, which include the name hey. I hit return, and sure enough, okay, it looks like computer gibberish. I'll grant that. But you can see that what we returned here is a patient resource. So it's saying I have a patient here. And if I go down here I have Harry Hay. And if I go down a little bit further, I'm sure I have additional. Here I have James Hay. But it's returned a series of patients. And so you can see that this isn't hard. This is not hard to program. If this were HL7 version 2, this would be thousands of lines of code. So back into the PowerPoint, the next thing that I wanted to talk about is semantics and how do you speak the same language between two different applications or between two different code systems? And how does the computer understand when you're speaking the same language? There are different code systems. I'm sure you've heard of some of them: LOINC, SNOMED, RxNorm, ICD-9, ICD-10, CPT-4 is used for billing. And this is just the tip of the iceberg. There are many, many hundreds of code systems. The code sets are the common vocabulary the computers as well as the physicians use to speak to each other. So here's part of the medication request, and this is something called JSON. Don't worry about this too much, but it's how computers code data. You saw it on the other slide as well. So here you can see that the intent is an order, and that for the code for the medication request, we're going to use RxNorm. This is just a long URL, but at the end you can see that it's RxNorm. And here's a number. This number is unique within RxNorm. In this particular example, we're ordering metformin. And then continuing on with the medication request example, as part of that same order, so this is a continuation of the prior slide, that units are really important to get them correct. I'm sure you've all heard the story about the Mars observer camera, that one application was using English units, the other application was using metric units, and I can't remember the number, but I want to say it was $350 million went poof. As part of the dose quantity within a medication request, you'll see that we have the value, 850, and then we also have a unit defined by another code system called units of measure code system. And so they'll actually show not only the value, but it's in a computer-generated and computer-understandable form so that we don't get it wrong. All right, let's go query one more time, because I just want to link all of this together. Okay, so just to show you one more time how to read an API or how to read a FHIR API, again, we've got a Chrome window, and I apologize for the size, but up here you can see that you've got the URL, happy.phir.org, and again, we're going to go to R4. This time, we're going to ask for all medications that have been ordered for a patient whose last name contains Hay. In the real world, you would never query for medications based on a patient name because there's probably more than one patient with the name of Hay. But for the purpose of this example, to keep it easy, we're going to go ahead and do just that. I hit return, and voila, you've got the 200 status code, which means that it was successful. I come down here, and now you'll notice that instead of getting patients, I got medication orders or medication requests. And as you scroll down, you can see exactly the content of the different types of medication. If I scroll down further, you can even see the doses and the rates. But that's how easy it is to build FHIR API. All right, so let's talk about some of the benefits of HL7. HL7 FHIR has security built into it, internet security, the same kind of security that you use when you log into your bank account on your cell phone or your laptop. This kind of security is not something that should be built by the healthcare industry when the entire internet has pretty much solved this problem. Another huge benefit of HL7 FHIR is that it has a query mechanism. We don't have to spray all this information and then try and synchronize it across hundreds of databases. The single source of truth is the electronic healthcare record, and we're able to query it. While that might seem pretty obvious, it doesn't exist today. Fast. The first letter in FHIR is fast. It uses APIs, it uses modern RESTful services, and it uses a data format called JSON. Don't worry about that too much. What you really need to know is that you can get newer applications delivered sooner because the implementation and the testing time just doesn't take as long. We haven't had FHIR out in the clinical world long enough yet. However, it is our expectation that FHIR will reduce the IT staff maintenance because they no longer have to maintain all these hundreds of databases and all these sprayed messages all over the entire institution. It should reduce the interface costs. Every time that you try to set up one of those sprayed messages, it's between $5,000 and $10,000 per message interface, not per message, but to set it up the first time and then to maintain it on an annual basis. And then finally, the benefit of FHIR is that the standard is open, it's free, and there's a huge FHIR community that's grown up around the standard. In conclusion, what do you need to do? What you need to do is you need to make sure that your institution includes FHIR in every contract request for proposal that your institution writes so that the systems that you purchase going forward include FHIR as opposed to only HL7 version 2. The 21st Century Cures Act is great. It begins to put a stick in place, not just a carrot, that these EHRs have to implement FHIR, but it's woefully insufficient. The alternative to not writing FHIR into every contract is that you're going to have to maintain the system where you've got the electronic healthcare record, which sends information to an HL7 version 2 interface, which then gets sprayed out millions of messages a day, and your IT system will always be monitoring this. HL7 FHIR is the way forward, and it's how we clean this up and are able to move on. Hope you guys have a great day. If anybody has any questions, please feel free to contact me. Take care.